Hello. Today in Lesson 7, we would like to focus on an important topic, visualization. So first of all, why do we need visualization? Actually, visualization or visual forms, compared to verbal forms, they're often much easier for your audience to understand. And because they're easier to understand, they allow you to provide clearer comparisons and enhance your logical organization. For example, down here you can see that with a verbal form or a form of a table, it might be hard to compare the assets of the company, while the graph can make it really clear. And therefore, we often use visualization for two purposes. The first purpose is to demonstrate processes and to show us all sorts of different things about our model construction process. And the second purpose is to display data. Now, let's look at some general rules for visualization. First, we need to note that visuals, or figures, they are part of the explanation process, and therefore they should stick closely into the explanation process. Which means that you need captions, because the captions can actually tell the readers what the figure is about, so the readers don't get confused on what piece of thing you put in the middle of your paper. And because you want to integrate your figures into your explanation process, you want to refer to your figures within your verbal explanation. And also, when you make the figures, you want to label it carefully so that it can be more readable. Next, let's look at the first example of visualizing processes, that is schematics. Essentially, schematics, you can use it to show related variables in different ways, so that it enhances your audience understanding of these variables. For example, if you have a geometric shape, like the one on the right, you can use several measurements on the geometric shape, and you can use the schematic to show how these measurements are related. Or if you have a dynamical system, which is a system in which variables are related by different rates, you might want a figure to show how the rates are related. And therefore, when you have schematics, the most important thing here is that you want to label them really clearly. For example, in the figure on the right, if you're drawing a geometric shape, you want to use perhaps braces to make sure that the readers know exactly which length you're referring to. The next method of visualizing processes is through flowcharts. So, what flowcharts do is they demonstrate logical flow, and it is really useful when you have really complicated processes that involve many decisions. And you can indicate logical progression using different ways. For example, here I have a simple flowchart that shows some of the most important elements of a flowchart, including processes, decisions, manual input, data, the start and the end. And the arrows indicate your logical flow. And sometimes when you have multiple arrows, you label them to show which choice leads to which decision. For example, the yes and the no following decision A. Finally, there are also other forms of visualizing processes. So, sometimes your flowcharts can also be riddled with complex logic. For example, if you're building a model about ambulances and houses, you might discover that your flowchart will require you to label things like ambulance A, ambulance B, ambulance C, which really confuses the audience. And therefore, you might want to use some more graphical forms to enhance the effects and make sure your audience is clear with which ambulance is which means, for example, you can show each ambulance. For example, in this figure on the right, I showed every ambulance and every house, and showed their relative distances, though it makes it more intuitive to the readers. Now let's switch gears and look at visualizing data. Essentially, visualizing data is about graphs and graphs and graphs. And different graphs would serve different purposes. However, some common thing about graphs is that most graphs, they all have axes, and in order to make your audience clear on what the content of the graph is, you need to label your axes of the graph really carefully. Now let's take a short look at different types of graphs. So if we only have one variable and we want to show the data distribution, for example, the distribution of the scores in a class, we may want to use a box plot, or a histogram. If we have two variables, one categorical and one numeric, for example, the categorical variable being the name of the book, and the numeric variable being the number of pages, we might want to use the bar graph. If we have two variables and both of them are numeric, for example, the number of days into an experiment and the temperature, then you may want to use a scatter plot or a line plot. Scatter plots are for data points that are relatively independent, and line plots are for data points that are related to each other and thus should be connected with a line. Or you can use a scatter plot with a fitted trend line in it. And if you have three variables, which turns a bit tricky, if you have two independent variables and one dependent variable, you have several representations. If your independent variables are discrete, meaning that they only take on certain values, you might want to try a heat map. Or if they're continuous, you can try a contour plot or a 3D mesh. However, with 3D meshes, it's worth noting that 3D meshes are often hard to read, and it is an optimal idea to include multiple perspectives into the 3D mesh, or else our readers will not be able to successfully interpret the mesh. And finally, if you have three variables with one independent variable and two dependent variables, then for example, it's like the numbers of days and maybe the temperature and the humidity. And you might want to plot with two y-axes, with one on the left and one on the right, or you may just use two plots. Finally, let's look at tiling visuals. So if we want to show a more complex idea, we might need several visuals together, and we want to tile them together into one big visual to make our paper more compact and to make it more clear. So in this case, we need to label each component A and B so that it's easier for us to explain what each component refers to. And this is an example in which I want to show both the temperature and the humidity. I use two figures and I put them together and label them A and B respectively to increase clarity. And that's what I have to share about visualization. Thank you for listening.